develop the results that we plan on that original problem definition or interval. I don't select the right to the additional advice, but the project first presentation, group 1. It's 9:14. I actually see some of our advisors. If you're there, thank you again. I'm just able to see the add-ons or new attention. See the name and group 1. I'm timing you, as you know. So I might chat 5 minutes if I sense that you're not going to finish.
Sure. So can you start?
I think we can start.
Okay, sounds good. Hi guys, let me share my desk first. Okay. Can you guys see my desk?
Yes.
Yeah. Okay, sounds good. Hi, this is JH. I'm part of the group 1. I'm very honored of the speech, the first presentation in our 2002 final Capstone project. So our group is the speech about the recommender system. What is the recommender system? Recommender system or recommendation engine is a piece of software that filter available information from the customers, the past purchase the history, using different algorithms to suggest the product or service to the individual customer. Will most likely to be interesting. Example, Amazon or some date matching system or the LinkedIn. We can find lots of different recommendation system in our website. So here is our small index. We're gonna talk about the logistics, about project, data engineering, workflow, modeling, dashboard, conclusion, and finally we showing the demo. Logistics. So as I say, the professor, our another main purpose is to make a good teamwork. I'm very happy to work with our team member. This is JH. I'm leading our team. I'm working as a product manager and the modeling part. John? Sorry, Justin?
Yeah, I'm Justin. I'm the lead architect here and budget manager.
Young?
Hi, I'm Muriel. I'm a lead scraper, and I did some modeling for this project.
And I guess I'll go as well. I'm John. I'm the lead visionary / master storyteller. What it really means is I focus more on the dashboarding and visualizations.
Young?
Your mic is muted, if anything.
Yeah, she might have some technical problem. So Young is the modeling, and she really has lots of effort. Maybe you can hear the Young voice later. Okay, how we the co-working together? Most likely, we using the Azure-based working process using the Trello. You can see that here, and we also using the wiki page using the Google. And also we have a daily and a weekly meeting, and so maybe our team member got a lot of stress out from me. Okay, now let's talk about our project. Ray?
Yep. So next slide. So our project is an Amazon apparel recommender system. So we've all encountered every day some kind of recommender system, sometimes in subtle ways, sometimes in not so subtle ways. So as JH mentioned, they're basically like algorithms, machine learning and deep learning algorithms that suggest relevant items to users basing on their data. And they've been very important to the modern e-commerce industry. If you don't have a recommender system in your e-commerce, then you need to get one. 35% of Amazon web sales were generated through their recommended items. So it's very important, especially for someone like Amazon or big companies like Walmart and Target. This study aims to construct an apparel recommender system for mainly Amazon users through user rating history, product images, and other other texts. Multiple learning deep on both readily available and engineered data set. And it resulted in this multi-step recommender system. And later we're going to show a Tableau to display results along with some evaluation measurements. Next slide. So here is a quote from Jeff Bezos, the CEO of Amazon. He said, "It's not an experiment if you know it's going to work." So Jeff is very big on experimenting. He's tried many things and he has been very successful so far with his experiments. And this project was definitely an experiment. We tried many things not knowing if they're going to work, and a lot of them didn't work as well, but eventually some of them did. So in a way, we're all like Jeff Bezos, hopefully. Another quote is very timely today from William Butler Yeats. "Education is not the filling of a pail, but the lighting of a fire." So let us remember that as when we graduate, this is not the end, but just the beginning. Next slide. So Amazon is one of the leading developers of recommender systems. And like I said, and as we all know, they've been very successful at it. But they actually started selling apparel way back in 2002, and were not very successful at first because people didn't trust buying apparel online. But actually now, since 2018, Amazon is now the country's leader in fashion retail, beating out competitors like Walmart and Target. So how did they do it? Well, as we know, Amazon is set up as a data company. We've used AWS. So we know that they're the leader in collecting, storing, processing, and analyzing data. And they have definitely used this to their advantage. Next slide. So how much do they actually make from their recommender systems? In 2018, they made about $112 billion just from their recommendations. So it is very important to them. And without the system, Amazon would be $112 billion poorer. Next slide. So who are our stakeholders and when we were planning this project? So we were thinking of presenting this to maybe some Amazon decision makers, the ones who would implement like the recommender system. Or we can present this to like other online apparel retailers, the one who probably wants a piece of the pie that Amazon has. And we also, but mainly we think about the Amazon customers, because according to Jeff Bezos, we always have to think about the customers to be successful in anything. And our objectives for this project is to build a model that can best recommend apparel that Amazon customers will buy, and eventually present recommendations to users. But selfish objective for us is for us to gain deeper understanding of recommender systems and the recommender industry. Next slide. So we have two hypotheses for this project. Our first hypothesis is that if we can mimic customers' behavior of purchasing product based on product ratings from the data set, then we can use that as our for our recommender systems. So this would be what they would call like some collaborative filtering. So we use users and data and rating data for this model. And then our second hypothesis is that if we can match the style of the customer's current selection, we can identify products that they are more likely to purchase. So we're thinking this is more like context-based recommender system. Next slide.
Okay, the solution architect part is the Justin.
Yeah, so I'll be going over the data sources, data acquisition, data preparation, and our evaluation strategy. So for our solution architecture, we really like to think about it end to end. So for the project, you like to kind of put everything out in front of the team so that we know what we're working towards and the different pieces that will go into making this a complete solution. So for our recommendation system, we kind of have 4 main pipelines. So first we start out with the reviews pipeline, and we collect our data from an Amazon S3 bucket, which the data set is already prepared, which is a collection of Amazon reviews and has already kind of been put together for us. We collect the data through an API, and then we do some transformation, some pre-processing, and prepare specifically for what we're going to use in our model. And then we do some training on that and then store the results. This is the first piece to our modeling pipeline. And then we also have 2 additional models that is the input to. We have a natural language processing and an image deep learning to complete our recommendation system. At the end, since we have, just one more piece.
Sorry?
At the end, since we have 3 different models that output results, to tie everything together, we put all the results in a graph database, and then we're able to analyze it through a dashboard and through an API. So for the reviews data set, we have almost 82 million reviews. This is really focused on user and items and review scores. So this is a very large data set, and it's typically helpful to kind of start small and scale as needed. The different features that we like to use were price, category, sales rank. We joined it with additional images and did some training on that. Okay. So as you can see, there's a bunch of different categories when you talk about Amazon reviews. We just focus on the clothing, shoes, and jewelry section, and we even broke it down further to just specifically the shoes. And once we got everything working for those categories, we eventually scaled up to clothing and jewelry as well. The example reviews data has a typical review ID, a product ID, the reviewer's name, helpfulness votes, which is how many times someone actually clicked that the review is actually helpful. So we have that data. We have the actual review text, the overall rating, and we have a summary of the review as well as the time that it was recorded at. And we looked at the data set as a whole a little bit, so we typically can see that most users are rating with 5 stars. There's typically skewed that way. Get the next slide. So for our data preparation, again, the 3 different pipelines all had their own specific transformations. For the reviews pipeline, we did a lot of removing the bad data. The initial data set wasn't always the cleanest, so we had to make sure we got everything prepared so it was better used for the models down line. So we also prepared it in a way that was efficient for our models. So we created some embeddings and some real condensed data sets that were optimized for what we needed. And the other 2 data sets, they were enhanced with additional data sources. So we web scraped the images from Amazon's webpage, as well as incorporated some metadata for natural language processing, which were also provided in that data bucket. To evaluate the models, we like to use our metrics and measure the performance over time. We have a few different tools that we use for that, but we also need to evaluate and measure the performance of our system. So we wanted to make sure that the code was processing efficiently, execution times are low, and this is very important when you try to scale. That's what I like about the Capstone project is it really shows you how to build these things when you're in a production environment. So thinking about those early and measuring them and seeing how you can optimize them will definitely help you out in the real world. Another thing we were monitoring was our budget. You know, not everything's free, and we also had a budget for this project. So tracking that over time and making sure that we did things efficiently and didn't waste money was also an important part of the process. Yeah.
Hi, this is JH. Let me cover the data workflow using the ML Pro and the SageMaker. One of the key parts to make a good quality of the model to achieve the right business goal, we need the pipeline because we need to keep improving our quality of the model and our goal. So we divided the 4 level of this 4 pipeline. First layer is the ETL data process. We got a low data and then massage to make some gold data. And second level is the machine learning training process. This layer is we using our multiple training and the experimental to make a good accuracy rate. Third layer is the tracking the model. Because to make a good model, we tried a bunch of different ways using the hyperparameter tuning or using the other model. But problem is hard to chase it. Sometimes we forget it, or sometimes we lost the data by ourselves. So we are using the ML Pro. We will show you the more detail in our demo session. Next one is the deploy model. Definitely someone need to testing for the A/B test, whatever differently, or involving the business people. Then we deployed our model to the S3. Model in the S3, we can using the model for the prediction part. So this is the one example in the ML Pro, what we using the keep core of the parameter and then the conclusion and the accuracy. Here is the graph, and then you can easily compare with the whole the parameter and then final one. Modeling. This is most funny thing, and then we spend lots of time to hear. Here is the full architect. As you mentioned, Justin, we have a total this amount is the unique product. So first level of our modeling is we reduce the 100 recommended product from based on the user's previous information. After that, we feeding to 100 product to the image-based recommender system and also the NLP-based the recommender system to narrow down the more small data. So So we make the last recommended product and provide to the customer. So one of the way using is I compare with the matrix factorization model, and another thing is a deep neural network based on the user's record history. This is the matrix factorization is using quite commonly in the recommender system. So in the here, we are feeding to the user in item data and then embedding. And finally, we just did using the dot product. So another approach is the deep neural network. In the here, if you compare with the previous architect, almost same input, item, input, user, what's the input, have both it. So we can adding the more different feature and then using the convolution neural network to narrow down the some final conclusion. This is the compare with the factorization versus the deep neural network. We can observe the big big difference. Matrix factorization usually showing the very low the accuracy rate, but the deep neural network is the using very high good result compared with the factorization. Yeah, could you cover it?
Yeah, let me quickly go over with the image-based recommendation system. So the idea behind this recommendation system is that if a customer shows interest into a certain product, the customer may also be interested by the similar products. So this kind of recommender system usually appears on the products page as you may also like sections. Next. So in our project, we for given product ID, we got our image data from web scraping using the Selenium, Beautiful Soup, and the Chrome driver. Finally, we sampled the data for 5,000 images. And the model that we used for feature extraction is called VGZ16, which is a pre-trained deep learning CNN model. This model has been pre-trained on 1.2 million ImageNet data sets, which have 5 convolutional layers and 3 fully connected layers. But since the since the last layer of this model is for classifications, we just used the output of the second fully connected layers, which we finally got 4,096 features. Next. So, and in order to have better understanding of the features, we use the feature vectors to visualize in 2-dimensional embeddings for some sample of the products. As we can see from this picture, like the sunglasses drift towards to the bags, and like sandals and slippers towards to the sports shoes. Next. And we also use the k-means algorithm to explore the number of possible clusters in this image data set. And we use the sum of the distance of the model up to 50 clusters. The result is shown in the left picture. Although in this, it is a kind of challenging to determine where the location of where the error occurs, but we finally settled down with the 15 clusters. And the picture on the right shows the products in each cluster in 2-dimensional projection. And we also use the TensorBoard to visualize the 3-dimensional embeddings, which we can more clearly see the clusters of the images. We will show this later in the demo. Okay, so for generating recommendations, we implemented cosine similarity matrix. It measures the cosine of the angle between the 2 images. And actually here we found that some of the products, even they have different product IDs, the images looks pretty similar. So I think that's because of they are from different sellers. So here we dropped the duplicate product with the same similarity score, and we selected the similarity score less than 0.95, and finally recommended top 5 products with highest similarity score. So this picture is some of the results from our image-based recommendation system. Yep.
Okay, Marie?
So to look for product similarities, we also did some NLP on some of the product features, particularly the title and the brand. Next slide. In particular, we did a TF-IDF weighted word-to-vec model. According to J.R. Firth, you shall know a word by the company it keeps. And this is the principle behind word-to-vec. It's a shallow 2 neural net that turns words into vectors. So that just means that words that we know to be synonyms tend to have similar vectors, and words that are antonyms have the similar vectors. So word-to-vec is neither supervised or unsupervised learning, but rather a self-supervised technique which back-propagates error. It reads the text and generates the labeled data from it. The problem with word-to-vec is that it treats each word equally, but we know that some words in a sentence are much more valuable than the others. In order to solve this, TF-IDF is used as a weighting statistic for word-to-vec. So we know that for TF-IDF, the value increases proportionally with the number of times a word appears in a document. But it decreases proportionally with the total number of documents in the entire corpus that contains the word. Next slide. So used as a weighting factor, it downplays words that appear frequently across the entire vocabulary, and which gives more emphasis on words that appear frequently only in a specific product title. This enabled it to give us a better representation of the semantics. The way it's done is we activate the output layer by multiplying the vector that we passed through the hidden layer. The hidden layer is actually the input vector times the weights, and it's entering the hidden node. Next slide. So because this is language, and language is very complex and varied, a lot of extra feature engineering needed to be done. So obviously, as with natural language processing, we have to remove the stop words and get the stem of each word. But I also needed to remove products with short titles because it's not going to give me a lot of information. And then we removed duplicate product titles that differ only in the last few words. For example, I put some examples here, like Tokidoki, the Queen of Diamonds shirt extra large, and Tokidoki, the Queen of Diamonds shirt small. So these are basically the same item, just different sizes. So I removed the duplicates of that. Next slide. So for this model, I used the Euclidean distance to measure similarities between vectors. The smaller the distance value, the more similar the two vectors are. So actually, why did I choose Euclidean distance instead of cosine similarity? The reason for that is if there are two vectors that are far away from each other but are actually on the same line, cosine similarity might consider them to be the same vector, but I want them to be considered different vectors. Next slide. So to visualize the model's decision, we plotted a heat map where each cell represents the Euclidean distance between two words. On the x-axis, the labels are the featured apparel title, and the y-axis are the recommended apparel title. The items are sorted based on the distance, and the top 5 recommended products are the ones that will be featured on the dashboard, which we will show later.
Yeah, dashboard, John.
Thank you, Miri and JH. So I'll be going over the dashboards and some of the visualization, including some of the dashboard that we built and some of the visualization we created. And these will be better exampled in the demo video that comes after this section. So JH, please go ahead. So this is the Tableau dashboard that we built. I'm gonna go into more details later in the actual demo, but to give you guys an idea, it basically consists of 4 panels, as the name suggested. On the top left-hand corner is the result from our deep neural network. Bottom left is the pictures of the products that our deep neural network selected. And bottom right is an image-based model result that Ink created. It's the output of that model. And the top right-hand corner is the dynamic function where it could dynamically display the item that you selected. That's the current web page of it. And to give a brief background of why we did this dashboard, it's kind of tying what our output would look like if we actually deploy it. So yeah, but as more of the details will come in the demo. Next. And this is the graph database that we joined the all 3 models together that Justin mentioned about. And it's really cool and it's very eye-opening in some sense. It very effectively communicated the advantage of our graph database. And with that, before we go into demo, next stage, let me just wrap up the conclusion that we have gone so far, because a lot of this conclusion will go into our demo as well as our visualizations in the demo. Okay, next. So a couple things. These are some of the insights that we have found. So first of all, data engineering on select data was actually more effective than us trying to tune various parameters that you have seen when JH showed you guys how we actually the workflow works, and then we try out the various different models. What we realized is we tried various models with various input, but it wasn't as effective as inserting dropouts. We realized that having less features actually has some in some cases actually it makes the model more accurate, less noise. Sorry, can you go back?
Oh, sorry.
That's fine. And a big part of our project is really the usage of cloud computing tools such as Amazon SageMaker and Databricks. It really provided a very effective model building environment and model building and tracking environment. And with this size of the data, the scalability, it becomes a really big issue, and those tools really help. So it didn't completely solve the problem, but it definitely helps the situation a lot. And our end model, what we saw is that our deep learning model with the appropriate dropouts, like I just mentioned, actually has the best performance in terms of overall accuracy in comparison to the matrix factorization that JH explained. And lastly, we built Tableau dashboard and some other dashboard as well. Tableau is just one of them actually. And it provides a very quick view on how the model outputs would look like from a customer's perspective. So we have seen all these matrices, but how does it actually tie to the actual product itself? And Tableau basically provides a very quick visualization of that. Next. So to wrap it up in just a couple sentences, we are aware that the model is not yet ready for deployment. As some recommendation are really, as we examine the output of the summer recommendation, it's not always ideal for every customer that we inputted in there. But we did make a big progress on working on the scalability of our model and get ready for that process with the tools that we already explained. And another thing we want to touch base on is how do we actually evaluate recommender system? Like we mentioned about with cosine similarity score and Euclidean distance like that. in the academic world, offline evaluation for a recommender system is usually revolve around like things like MAE and recall. And online visual evaluation in the actual business world, like Amazon, they actually focus a lot on A/B testing on ROI, right? Return on investment. That's really what they evaluate based on. So, and some of these, like the one that business world focus on, although we want to measure those kind of things for our system, but practically it's just not it's not possible with the setting of our environment and the setting of our data. But if possible, that's something definitely when a deployment happens, that's something we definitely want to track. So that pretty much wraps up our entire project. But we do have a short little video that demos what we basically our result. So let me
unshare my screen and let's see the John screen.
Okay. Sorry. This is, yeah, I think this is the right one. Okay, so we're gonna be silent playing this video, but just know that it's actually voiceover, just for the purpose of passing our information down in our library archive and everything else. But we'll be pausing video somewhere here and there, because our pace when we actually demo it in front of you guys is gonna be different from how we voice over it. All right, with that being said, let's start the video, and JH, please go ahead.
Okay. First, what I'm just showing in our recommendation is how much we improved the accuracy rate. So this is the based on the learning the effort, you can see how much improved the accuracy rate. So this is a good monitoring using the ACC, the F1 score, how much, and also we can prevent it as overfitting through the. And next one is the how we tracking all of our activity using the different parameter. This is the ML flow developed from the Databricks, and you can save the whole hyperparameter and then a model artifact, summary, everything in the one place. So another good thing is free. It's open source, so you can feel free to using it. So you can also make some easily compare. Easy, right? It's highlighting the different part. And also you can see the graph compared with the other model. So yeah, so I highly recommend. John, could you keep leaving so we can keep showing? Yeah, thank you. Could you play the video?
I mean, going forward, backward.
Just play the.
Okay.
Yeah. So yeah, we can see again, but this is good. Okay, Young, could you explain?
Yeah, this is the TensorBoard we created for embedding visualizations. TensorBoard is a good visualization tool that provides the insights of the data set for machine learning training. It can visualize the matrix, project the embeddings, and display images. So for this visualization, we use the 774 samples and with 4,096 feature vectors as the input. And we also labeled our images with the product IDs. So even either we can show the product ID or we can show the images for the three-dimensional PCA. So, and here, if we like click one specific product, it will gives us a list of the nearest neighbors with the product ID and the distance between the products. And here we can also choose different numbers for the neighbors, or we can choose different matrix for, we can choose a different distance matrix. It is really helpful for us to have better understanding about the features. So when we isolate these points, It just shows these 26 recommended products, and we can check the distance between the recommended products. And also in TSNE, we can look at images more properly in clusters. So now it goes to TSNE. Here we starting clustering the images.
Your fruiting products.
Yeah, and here we can see there's sunglasses clustered together, and boots and the bags are clustered in one cluster, and some high heels, some sneakers, they are in same cluster. And we also can setting different parameters in the left side. You can see there is like learning rate, supervised learning rate. Yeah.
Mary?
Yeah. So for the natural language processing TF-IDF weighted word to vec model, so the way this model works, well, we made a dashboard for this particular one. The way the model works is we first get a featured item from the explicit feedback model. Then when we select one, the top 5 recommended products shows up from the NLP model. And then when you select it, we visualize the model's decision to visualize the model's decision. We plotted a heat map where each cell represents the Euclidean distance between 2 words. On the x-axis are the featured apparel title, and on the y-axis will be the recommended apparel title. Okay. What's happening? Oh yeah. So here is an example of the heat map. You can see that the title pretty much matches. One is a Kate Spade Ali Trias aviator sunglasses, and one is a Kate Spade Women's Marion aviator sunglasses. So this model was able to recommend these 2 very, very similar items just based on the product title and the brand. Later on, there actually this model works pretty well visually. You will see later when click through here, this model was able to recommend pretty similar, even visually similar products, even though it just uses the text.
Yeah, so we are slightly, looks like over the time. We have only 5 minutes. We have a tons of want to see it together. Yeah. Let's keep moving. The next part is the actually to understand the whole relationship together for data using the Neo4j. So Justin?
Yeah, so again, we have the similarities outputted from the different models, and by creating those relationships in our graph database, we are able to run queries that will basically combine the different similarities. So users that purchased certain items, their similarity score, as well as the image similarity score and the title similarity score, and then we can return those results to an API. And that's basically what the customer sees as a combined similarity to. Okay. This is just walking through the actual graph and what it looks like. So there's 2 customers here and all the different products that they purchased. You'll see the connection of the 2 items that they have in common. Yeah. Yeah, this is the collaborative filtering based off one user, kind of what it looks like. You can see the different, there's 3 layers here. There's the users who purchased a certain item, what the user that also bought them, and then this also goes 1 layer further of users that bought the items with that user bot. It's kind of nice to see, and if you really get a chance to look into it closer, there's a lot of information that really unveils.
Okay, so we have one to showing it as a dashboard, the conclusion report.
You can just go to the dashboard.
So
Definitely, you guys can watching the full video in the YouTube.
So yeah, this is the dashboard that I have demoed earlier. Well, to explain earlier, like the 4 panels. Again, the goal of this dashboard is to really visualize. We have talked about all these cosine similarity and all these statistical measurement and evaluation we've done on each model. But how does it tie to the products, and how would it look in the eyes of our customers when we actually deploy a model? So this kind of served as a sanity check to see, hey, does our model make sense? Because previously, all our model outputs are either in single pictures or in some sort of score. Okay, so in this video, I demoed two cases where one is we think we found a good match for the user, and another one I would think our model actually fails to do so. So let me fast forward to that part. So this one right here, actually, the functionality we built in there is we can select the user ID. Obviously, we modified the name of the user just for the demo purpose. But this is a case where we think our model performed pretty well. So you can see the recommended model based on neural network is a King Woman's Boy hiking shoes. And the product we recommend here that from the neural network model, which is the top 10, we picked the top 10 to show here, display. Somewhat makes sense. It's in the same category. And our image-based model also recommended products that are in similar category, which is in sporting/hiking category. And we can click this button to actually see what this product looks like and price of it and the current situation in the top right URL panel. But there are also cases where it didn't work as we expected it to be. Let me fast forward to that. Sorry. Yeah, so so the top one, this is another user we think it failed. So, okay, there we go. Top right-hand corner, the highest predicted product is bed, stew, woman, opal boots, which is actually this one. But what our image recommended, first of all, the neural network doesn't seem to be recommended all the products in a similar category. And our image-based model seems to confuse this boot with someone's actual foot. So you can see that it recommended a ballet and some sort of healing equipment. So we are aware of this situation, and due to the complexity of image processing, there is limitation to it, and there are still more road bumps that we have to clear out. But this Tableau dashboard served for that purpose. It gives us an idea, say, hey, does our model work as we expected? And if not, let's find those users that's not, and we can perhaps find a pattern and improve this model. So this is really what that Tableau dashboard is really for. So with that, we conclude. JH, go ahead, conclude our presentation, please.
Yeah, sorry, we are lack of time. So thank you, John. Could you take screen sharing?
Yeah, sorry, we'll do that.
Mm-hmm. Thank you. So thank you, John.
Thank you, Group 1. We have a couple minutes break.
But I really appreciated the professor and our advisor, Julian professor. So, yeah, simply.
So, unless there is a burning question, we can have one question before 10:05 or take a 2-minute break and make the switch to Group 2. Any questions? So I want to comment that we had an earlier data set for a couple different Amazon projects over time, as you know, as you've seen in the archives and things like that. And one of our earlier graduates, Jamie Ryan, worked on another Amazon project. I wanted to ask what he thought of this project and how he thought it compared.
It's impressive. It looks like there's a lot of new methods that are being used, and some cool visualizations. I don't think in our cohort anybody got TensorFlow into the Amazon data, so that was fun to see the 3-dimensional grouping of shoes in the cluster. Yeah, there's some cool visualizations too. Thanks, happy to be here.
Thanks, Jamie. Thank you again. Great presentation. I think everyone can turn on their virtual class.
Thank you.
Thank you. Let's try to switch to group 2, and if you need to take
to deploy the models as an endpoint. So if there's a team that wants to ingest new data into this type of model